All right, so this part of 9B, you can see it says part 1, so that assumes I'm assuming there's also a part 2 here because it's a little bit long. So we're going to split this up into two parts, yeah? And then we'll do part 2. Maybe we'll see how we go today if we have time, but we're going to aim to try and do part 1 of 9B. All right, so for this part of the lesson in data, actually, yesterday, does anyone remember what we had learned about? And numerical data. Yeah, so do we remember what each of those words mean? What is categorical and what's numerical? Yes. Yep, so data that you can put in categories. Yep, so it can be data that's essentially it's describing something, which I mentioned yesterday. It's describing things. Yeah, what's numerical data? Yes. No, I don't. Okay. It's numbers. Okay, it's numbers where you're either measuring it or you're counting it individually. And one way that I can think of it as well is you can make some sort of mean, median, mode with it. Whereas with categorical data, you can't make a mean, a median, or a mode. It's just describing things. Okay, so think about that when it comes to thinking about the types of data that you work with. Does anyone remember the subtypes of the categorical? What do we have? Lana? Is it nominal and ordinal? Nominal and ordinal, good. Does anyone know the difference between the both? Nominal and ordinal? Yes, Alana? Or order of some sort? Nominal, not really, because you're just nominating something, you're naming it. Okay, what about numerical data? What are the two subtypes? Yes, Akela. Discrete and continuous. Georgie, do you remember what discrete data means? Okay, you can look at your notes if you like, but what does discrete mean? There's an unlimited amount of values or a limited amount? A limited, good. Which also means, are you counting it? Okay, it's usually whole numbers as well. Whereas for continuous data, it's numbers that you're measuring. Okay, so you remember that. And there could be like decimals in there involved because you're measuring at small increments as well. So it could be like measuring the length of your hair, measuring the distance that you walked, or measuring the amount of water there is in something. All right, so just remember those variables, yeah? Now, when it comes to graphs and making some sort of visual representation of our categorical and numerical data, we can use graphs for that. Yeah, and generally speaking, if in year 11, what we teach you, the whole point of data is you need to be able to interpret it or make sense of it. There's no point in just having data here if you can't do anything with it. Okay, and that's what people do if you ever decide to, move on from school and find a career in something, you'll find that if you ever do something like accounting or something with money related, or even anything business related, you're looking at data and you're interpreting it. Okay, you're always interpreting data. You don't just have it for the sake of it. You have to do something with it. So one of the main things to do with data is we use it for graphs. Okay, we're going to be graphing all of our data in some way. So our learning intention is to be able to, and I want you by the end of the session be able to construct some sort of graph based on whatever data you have. Okay, and then be able to, as a success criteria, identify and explain. I want you to explain the different types of graphs that you can use. So why is a bar graph better than a dot plot? Why is a stem and leaf plot usable for this, but maybe not for a box plot? Okay. And identify the best suited data for it, whether it's categorical or numerical data. Okay, what's better? Is it better to use a frequency table or is it better to use a stem and leaf plot? Depending on what you have. Okay. And then I want you to be able to draw every type of graph that we're going to go through today. All right, so let's get into it. So we talked about this yesterday, examples of numerical. Remember, you got discrete and continuous. If you ever need examples, okay, or there's a question on your CFAT where you're asked to come up with examples, use this. Put it in your bound reference. Okay, just chuck that in there. That works. And again, notice that with discrete, you're counting things individually. Yeah, but with continuous, you're normally measuring things. All right, and then actually, there's no categorical data, but that's all right. All right. Yeah, there isn't. All right. When it comes to displaying data, okay, you've got either a graph of some sort or a table of some sort that you can use. Okay, and there's also, however, things that are more beneficial. It's better to maybe make a graph that looks like this as opposed to that, depending on what you have. So here are some examples that, again, you could go with depending on the type of data. If you have categorical data, okay, remember categorical, you just it's not numbers. You're just looking at essentially the number of how many of like you're describing something. Remember that. So it could be, for example, burgers, chips, and pizzas. Okay, the number of each one. It could be you're trying to measure how many people like different types of cars. Okay, so for categorical data, and you can see for categorical data, it's better to use a frequency table or a bar chart or a segmented bar chart or a dot plot of some sort. So we're actually basically going to focus more on the categorical, I think, for today, but we'll see how we go. So frequency table, bar chart, segmented, and dot plots. For numerical data, so now you're looking at data where you're counting things individually or you're measuring things. Okay, it's better to use, or you could still use a frequency table, but now you've got histograms. You can also use dot plots, a stem and leaf plot, and a box plot. All of these we'll go through today. Actually, does anybody hands up if you know any of these? You guys worked with any of these before? Only a few of you. So does that mean a lot of you don't know what these are? Yeah. Yeah. Can anyone tell me maybe what is a dot plot? What does it look like? Give me a description of it. Dots, yeah. Alana, what do you think? What is a dot plot? Good. So it looks like it's a line on the bottom with a bunch of dots on top. Cool. What's a segmented bar chart? I don't know what that is. It's a bar chart with segments. As it alludes to there. Yes.
What graph is the one that's got like the dot on it and then you like draw a line?
Yeah, so that's a line graph, but that's by area. So you're going a bit ahead, Mr. Spurrier, but that's cool. It's good that you know that. Stem and leaf plot. Do we know what a stem and leaf plot is? Yeah? Does it look like this? Is it like a leaf with like a bunch of... Is that what it looks like? Yeah, kind of. Pretty well, yeah, that's why it's called a stem. And then you got your leaves. But it's, remember, it looks like this. It's got the stem here, got a bunch of numbers, and then you got more numbers here. Okay? We'll go through it as we go through the lesson. All right. Types of data. Here we go. You got frequency tables for, so this is for categorical data, yeah? Frequency tables, you can see there. Okay, you've got some sort of variable here, and you're counting how many of each, and then you're coming up with a percentage of it overall. So you can see here, you've got the degrees, or the degrees that people obtain in uni. You can see in this group, there's 40 people in total. 2 of them only have high school, which creates about 5% of the data. Okay. Here you've got also 3 people who've got a master's degree. 4. Okay. Out of the 40 people, it's only 3, which is 7.5% of the data. Okay, that's how we use frequency tables. Dot plots, you guys get it. It's just a line with a bunch of dots. And what do the dots represent? What do the dots represent in a dot plot? Unit, maybe. Kane, do you know what are the dots? The people or the number of people in that. So, for example, how many dots are on top of pretzels? Kane? How many dots on pretzels? 4. So that means there's 4 people that probably like pretzels. All right. So that's what we use dot plots for. Bar charts, or we can also call them column graphs. They're actually kind of similar to your dot plots, yeah, but they're just in the form of a bar this time. Okay, yeah, it's probably the easiest one to get. The cool thing with bar charts, and you just need to make sure you understand this, yeah? Notice how there's gaps in between them. Yeah, there has to be gaps. Whereas with histograms, it's a bit different. And then mode is the highest bar. So in this case, the medium is the mode here. Medium, sorry, not median. Lastly, and your segmented bar charts are a little bit different, a little bit trickier. But what we're looking at there is you've got a bar chart, but there's segments within it. It's hard to draw this. So what you can see is, so for example, if I go with, so what this is saying, the pros of literacy level. So where are people at with their literacy levels? All right, and you can see here, for example, if I go intermediate, people who are in intermediate, you can see that there's about 20% who do that activity. And then you've got about, what's that one? That's 20 to 45, so that's about 25%. So each of these bars, okay, represents a certain number. So that's about 20%. And you've got to see where it lines up with the actual graph. You may or may not have done these before. And then up here, you've got 50, I would say that's about 55%. What do you guys notice when you add all this together? What does it add up to? 100%. Okay, so that's how segmented bar charts work. All right. It depends on the data, so it makes more sense if there's a question behind it. But what we'll do is let's practice the frequency tables. Okay, so if you've got that on your page, it should be blank. It's on the bottom. Let's do this one. So we need to construct a bar chart and then a frequency table first, and then a bar chart. All right, so let's do this together. Every frequency table, you're going to be asked to draw this in your own stats and secrets. By hand. I want all frequency tables to look something like this. So you're going to have 3 columns. Okay? So whatever the variable is, the frequency, which is the number of those variables, and then the percentage. And I'll show you how to work that out. And on the bottom, you've got the total. Alright, so first things first, what you'll do is on the color, I can see on this following data, you've got blue, red, and yellow. So there's 3 colors. So we're going to put all that here. Blue. Yep, let's do it. Fill it in. And then you've got red. And then you've got yellow. Is that filled in on yours? Okay, good. Yellow. Sorry. You guys see that? Yeah. Okay, good. Okay, and then from there, what you're doing is you're just going to be counting how many of each of the variables there are. So, for example, in blue, I can see that there's, and I like to do this, I like to cross it out as I go. So I know that I've counted it. I've got 1, 2, 3. There's 3 blues. So on frequency, there's 3. For red, all right, let's count that. You got 1, 2, 3, 4. There's 4 reds. Okay, and then for yellow, I can see you've got 1, 2. Actually, I counted, one miscounted with red. There should be 5. Sorry, 5. Thank you. And then for yellow, there should only be 2. All right, so underneath in the total, we put the total for the frequency, which in this case should be 10. Okay, so it should be 10 altogether. Now, with the percentage frequency, okay, you may want to write this as a formula, but all you're doing for that is you're going to go the frequency. I'll put the formula here for you. So the frequency divided by the total times 100. Okay, so that's the formula we're going to use for the percentage frequency. So all it is, let's look at blue. For blue, you've got a frequency of 3 divided by the total of 10 and then times it by 100. So therefore, the frequency of that will be 30%. All right, for red, okay, you've got a frequency of 5. So it's going to be 5 divided by the total of 10 and then times it by 100, which equals 50%. And then for yellow, okay, you've got a frequency of 2. Okay, and then you divide. Look at the formula if you forget it. Divided by the total of 10, and then times by 100, and that gives you 20%. Now, mathematically, what should the total be percentage-wise in the bottom? It should be 100%. Yeah. Thing is, though, sometimes when you do this, and you depending on the rounding that you do, it might be like 99.98 or 19 or 100.01, and that's okay. All that matters is that all of this it should equal up to 100. Okay, so it might depend on your rounding, depending on the values that you have. All right, so the next thing now is we need to translate that to our bar chart, right there. Okay, bar chart, bar graph, either one, that's fine. So now just look at the variables on the bottom, or if it's not there, write them down, and then you're going to make a bar for them. So according to this, we've got 3 blues, yeah? So that means our bar for blue should just go up to 3. Okay? For red, okay, your bar should only go up to 5 because you have a frequency of 5. So draw your bar so it just goes up to 5.
10, 0, 8,
And then for yellow,
9,
okay, you should only have 2. So that means your bar should only go up to 2. You don't connect these ones. You connect it if it's a histogram. So with the bar chart, remember there's gaps between the bars. Okay, so again, don't forget how to do these. You'll need to essentially be able to do this on your own when we do the CFATs, yeah? You can if you want. You don't have to.
no, I don't.
Okay.
No,
Does that all make sense, guys?
dot pot.
Nothing too crazy, yeah? Okay, let's now move on to the next thing. For actually, just got a couple more, and then we'll do work. Okay, it's getting there. We're nearly there. All right. Next thing is this categorical data. So the first part was looking at numbers and numerical data. Now it's categorical data. And remember, for categorical data, it's categories. Yeah? You've either got nominal data, where you're just nominating it, or there's an order to it, depending on what you're doing. Just be mindful. Okay. I think I mentioned it yesterday, but when we talk about, for example, your address or your postcode or where your house is on the street, that's actually not numerical. Yeah, it's categorical data, and it's a nominal data in this case. But let's say, for example, you've got your addresses. That's probably going to be ordinal, but so as you can see here, organizing something in order of lowest to highest. So just keep that in mind. Some people get confused about that. But just keep that in mind. Yeah. All right. Let's go and do some of this. Let's do a segmented bar chart. Okay, and this will kind of make more sense now because we're doing an actual question. So we need to look at our data and see again how much of each we have. So our frequency tells us that in total there should be 10 altogether. Yeah. So if you look at that, let's look at the colors. For blue, I can see that I've got 1, 2, 3, 3. So all you're doing is for colors for blue, you're going to draw your bar up to 3. Just there. And that's our blue. Next one, let's look at red. For red, I can see you've got 1, 2, 3, 4, 5. There's 5 reds. Now, think about this, yeah? At the moment, we're at 3, and there's 5 that are red. So we're at the number 3. Okay, that means we need to go all the way up to 8 for red, because this means that there. See here, according to this, you've got 3 blue. Okay, according to this, you've got 5 red. Okay, and then what's the remainder, guys? 2 yellows. So that means on our bar, if we're up to 8, we need to draw a bar up to 10 now because that's 2 spots. So right there, you've got 2 green. Oh, sorry, yellow. My bad. Okay, that's how your segmented bar chart works. And the way this works is you might have perhaps multiple variables. One could be color, the other one could be shirts or pants or something like that. Or it could be sizes, but all in the one graph. Yes, you could have multiple things happening there. And that's how like segments work. Okay, you can think of it as a bar chart as well, but it's just segmented because you might have multiple variables. Okay. And again, the height of each column is equal to the number of the total number of data. So again, this height
Yes.
tells us, so overall,
Get bread.
if you add everything up, that should add up to 10 because it's 10 here on our frequency.
You good?
And each segment tells you how much of each there is. All right, next thing, let's draw a dot plot. So for your dot plot,
Laptop.
again, you just start off with a line,
Right now.
okay? And then you draw your variables on the bottom.
What laptop?
So our variables are blue, and then red, and then yellow. So according to this blue, how many blues do we have, guys? 3. So you should have 3 dots on top of the blue. For red, you've got 5, so you should have 5 dots.
Okay, so go toilet.
For yellow, you've got 2.
No.
Right? Nice and easy.
No.
All right. Any questions about that? All right. I'm going to move on to the next part and just being able to display different types of numerical data as well now. So numerical data, again, remember with numerical data, you can have means and medians and modes, and these are the sorts of data displays that we can use for them. So you got frequency table. So what you'll notice is you can use a frequency table for both categorical and numerical. And it's the same dot plots. You can use it for categorical and numerical. Now, where it's different is for numerical data, you can only use stem and leaf plots, but you can't use a stem and leaf plot for categorical data. Do you guys know why? Why can't you use a stem and leaf for categorical? Have a think. What does a stem and leaf have? Numbers. Yeah, you're working with numbers in stem and leaf, so it's not categories anymore. You can't use stem and leaf plots for categorical data. Same with box plots. Yeah, you're using numbers now here, so you can't essentially use them for categorical data. And same with histograms. Okay, and Attila asked before, what's the difference between a histogram and a bar chart? With a histogram, there's no gaps. And the reason why is because there's a range of data in there. So between what this bar is saying is between 9 and 9.9. This bar is between 10 and 10.9. This bar is between 11 and 11.9. So it's numerical data where it's, again, numerical, you're measuring things, so the increments become a little bit less, a bit more, sorry. All right, let's try and make some of that data. So let's go with a histogram for frequency table and then into a histogram. All right, before I actually get into it, does anyone know how to read these numbers? What does these 0-10-20- mean? I don't know what that means. In a histogram that looks like a frequency table that looks like this. Yes.
0 and above, so it would be like, it would go, the way that I look at it would be at range, so you'd have like 10 through 19.
Okay.
10 to 19, the next one would be 20 to 29.
Yeah, so what does this one mean? 0 to what? 9. Good. You know, it's not there, but it's implied that this dash means 0 until the number before the one below it. So it should be 0 to 9. This one here means 10 up to the number just below 20, which is 19. And this one will be 20 until the number below 30, which is 29. Now you notice that the last one is just says 30 to 40. And the reason why they always do it in the very last one only. Okay, and the reason being is because there's probably nothing above 40 after that. Okay, no more. So they just finish it off at 40. Okay, so let's look at that. So from 0, so remember that first one is saying 0 to 9. So how many numbers do we have that are between 0 and 9? Well, I can see there's 1, 2. There's only 2 there. So the frequency for 0 to 9 should be 2 numbers. Okay, there's 2 numbers that are 0 to 9. 10 to 19. Okay, let's have a look at that. I can see there's 1, 2, 3, 4, 5. There's 5 numbers from 10 to 19. Okay, 20 to 29. Right, I can see you got 1, 2, 3, 4 numbers from 20 to 29. And then 30 to 40, you've got 1, 2, 3, 4 numbers. Cool. Now we put the totals. So remember the total is just the total for the frequency. What's that? 8 plus 7 is 15. There should be 15 in total. I use black for that. Okay, and then after that, it's the same procedure as you would for your other frequency table. So does anyone remember the formula that we came up with for it? Frequency divided by total times 100. So the frequency divided by the total. That looks like frog, sorry. Let me zoom in a bit. FREQ divided by the total. And then you times it by 100. And that's how you get your percentage. So let's just work it out. So for the first one, it's 2 divided by the total of 15 times by 100. Now, I'm not smart enough to do that. So use your calculator for it if you can't get it. 15 and then times by 100. And that should be 13.3. Now, again, remember what I said about rounding. Sometimes your rounding will affect your percentage frequency total in the end. But it's okay, as long as you're very close to 100%. So that's 13.3. Next one, same thing, but we're at 5 this time. So 5 divided by 15. That should be 33, I think. So again, you don't have to technically show the working out. It's okay. 33%. Next one is 4, and the same with the other one after that. So it should be the same. Okay, and that would be 26.6. And it'll be the same for this because it's also 4. Okay, so 5. You can go 4 over 15 times 100. Yes. You could, yeah. It does. It does. You're correct. So you could round it. Although in my calculator it doesn't say. Oh, it does say recurring there. So you could make them both 0.7 as well. If you didn't, though, what do you think would happen to your answer? It'd just be like 99.999, which, again, is okay because it's close to 100, depending on your rounding. The question doesn't ask us to round, but we can this time round. And if you add it all up, it should equal 100%. You can just write straight up 100%. You don't have to go 99.98 again because of your rounding. It doesn't really matter too much. Okay, next is now we draw our histogram. Is that blank on yours? The histogram? Yeah. All right, cool. Now the histogram, remember, okay, just be mindful of how the data is being, the interval here. Okay, so with the intervals, please be mindful of it. So for the first one, remember, what is this saying, guys? 0 to what? 0 to 9. Okay, not 10 to 9. It's just before the next interval, whatever it is. So that means from 0 all the way to 9. Now, I'm going to draw my bar up to 10, but that doesn't necessarily mean that it's from 0 to 10 yet. It's 0 to just before 10, which is 9. So according to this, I've got a frequency of 2. So your bar should just go up to 2. Oh, ugly. Oh. Okay. Mr. Tony cannot draw today. Sorry. All right. Okay, that's good enough. Next one. Okay, what is this saying, guys? 10 to what? 10 to 19, yeah? Not 20, 10 to 19. So that means on my bar, just keep that in mind, but I'm going to draw 10 to 20 here anyway. But just remember, it's 10 to 19. I have a frequency of 5. So your bar should just go up to 5. So I'm going to draw my line up there.
Excuse me. I know that it said no casual clothes.
And remember as well, guys, that there's no gaps in between your bars here because you're working with a range for your data here. Next one. Oh, let me fix that up. Sorry. It's gone a bit over. Okay. Next one, you've got 20 to 29, and it's a frequency of 4. All right, so that means my bar from 20 all the way to 30 in this case, but remember it's 29, just goes up to 4. And then the last one is the same thing. So 30 to 40 also goes up to 4. Let's use a different color. So the last bar, 30 to 40, should be the same height as this one. Okay, and there is your histogram for it. If you really wanted to as well, to make it a bit more clear, you could color them in just so you can see the bars a bit better. And what I've told some kids to do in the past is you can actually draw the frequency on top of each bar as well, so you know how much there is. So, for example, from 0 to 9, you know that you have 2. From 10 to 19, you know that you have 5. Okay, from 20 to 29, you have 4. And from 30 to 40, you also have 4. So that also helps so you understand how much of each there is. If it's really hard to sort of line up the bars a bit, that also just helps with drawing the frequency of each bar. All right, any questions about this one? I think we're up to the last one, and then I'm going to let you guys start working. Oh, a few more, sorry. Nearly there, nearly there. Couple more. A couple more. All right, let's do a stem and leaf plot now. Nearly there. So again, stem and leaf plot, numerical data. You can, yes, but just be mindful that if you do, when you add them all up in the total here, it might be like 100.01, and that's okay as long as in here you write 100%. That's what matters. Okay,
Excuse me.
so the rounding's not too big of an issue.
This is what happened.
All right, next one and the second last one here. Actually, we won't do this one. We'll just go straight to this one. All right, next is the stem and leaf plot. Remember, still numerical data. For this, we need to draw a stem and leaf plot, draw a dot plot, and then find the median. 3 things. All right. Have you guys ever seen a key in a stem and leaf plot?
No.
Yeah? So do you guys know what it means?
No.
Yeah? What does it represent, Attila? So let's say I wrote something like this. 2-3 equals 23. What does that mean?
So when you got the 2 on the left hand side.
Yep. So if you got a 2 on the left side and then there's a 3 here, you read it as 23. Okay? However, here's the thing, yeah? If I had something like this and my key was like, I don't know, 4-1 and then it's 4.1, what does that mean? So decimal. So if it's like 4 and then 1, you don't read it as 41. You read it as it's 4.1. Okay? So this key determines like how you read a number. What if you have 20-1? It means 201. Okay, so that means when you see a number here that's like 40 and then 3, how do you read that number? It's 403. So the key tells you how to read the stem and leaf plot. Okay, all right. So for you, I want you to come up with your own key. Or actually, we'll come up with one together. Let's say I see a number and it's like 1. We'll go 2-7 equals 27. So we're reading, because look at the numbers, yeah? We're reading it as 9, 10, 18, 18, 19, 20. So the numbers are actually whole numbers. They're not decimals. So you have to use an appropriate key for it. Now, on our stem and leaf plot, I can see the numbers go from 9 all the way to 40. So what I'm going to do here is, if you look at the
He's crying.
tens units, you can see that you have individual numbers, and then you have tens, you've got 20s,
Very badly.
you've got 30s, and then you've got 40s as well. Yeah. So on our stem, you need to make sure you count for it. So here you're going to go 0, 1, 2, 3. Because what this represents, and then 4. These are your single units. These are your tens, 20s, 30s, 40s. That's what that represents. All right. So on our leaf, the first few numbers you need to. Oh, one more thing. On your leaf, make sure your numbers are either lowest to highest. Okay, lowest to highest must be.
No, you don't.
All right. So our lowest number is a couple nines. So on my leaf,
I'm
you're
very
gonna go 9,
sick.
9, and then 9. Okay. 9 and then 9. And how you read that is 0-9 means the number 9. Next one is you've got 10, 18, 18, 18, 19. So on my leaf here, 0, 8,
Doctor is
8,
very angry.
8, and then a 9. Yes,
Doctor is angry.
it helps, yeah. Because if you just leave them like this, you might get them mixed up. Just helps. Or space them out a bit so you're not getting confused.
No trains.
Alright, so I've done, and again, cross them out as you go, so you know that you've done those numbers. Next one, you got a 20, 25, 27, 27. So 20, 25, 27,
Relax and
27.
play.
Cross them out as you go so you know.
He's crying, Surya.
Next one, 33, 35, 37. Alright, so in our 30s, you're going to go 33, 35, 37. Alright, and then the last one is a 40. So it's just going to be 40. Easy, yeah. It's not that hard. We might. We'll see how we go. I think most of these questions are just basic ones, so nothing too crazy. Alright, next one. Let's draw the dot plot. Nice and easy. So be mindful. Just wait. When it comes to a dot plot, you don't want to do this, yeah? And a lot of kids make this mistake. They go, for some reason, you guys do this. 9, 10. Oh, you got to go 9 and 10 and then 18. And you go 19 and then 20. And you get 25. And you get 27. Okay. You don't want to do this. No, so I'll show you how to do it. You don't do it like this, yeah? This is wrong. And you got a 10 and you got 3 18s. That's not right, okay? The reason being is what's happened between 10 and 18. You've skipped a bunch of numbers. Okay, between 20 and 25, you skipped a bunch of numbers. So this is the proper way to do a number line or a dot plot. Okay, you can see your numbers start at 9 and go to 10. I'm just maybe going to go up by 5s. Or you can even go up by 10s if you want. But I might go up by 5. So it's going to be 5, 10, 15, 20, 25, 30, 35, 40. Okay? You don't want to skip any numbers. That's the issue. That's the thing with this. Alright, and now we need to look at our numbers. So I'm going to scribble out, I'm going to take off my marks so you can see what numbers we're working with. So on your number line, you need to figure out where those numbers fit. So for example, I've got 2 9s. So on my number line, where would the number 9 be? Just before 10. So that means you're going to have 2 dots just there. Because that means you've got 2 numbers, which are 9, that are below 10. Okay, and how many do we have that are 10? Got 1 dot, so that means just above 10, you're going to have 1. How many 18s? 3. So find out where is 18 in my number line. Well, if that's 17.5. 18 is probably here somewhere. So you got 1, 2, 3 dots on 18. You've got 1 on 19, which is just before the 20. So that means 19 is right there. And then you've got 1 right on 20. So you've got 1 right there. 1 on 25. So you put your dot right above 25. You've got 2 27s. So that'll be about here. 1, 2. Okay, and then you've got one number that's 33, which is just before 35, so over here. You've got 1 on 35. Okay, you got 1 on 37, which is probably about here. And then one number on the 40. So that's how we do a proper dot plot. Do not skip any numbers or use proper intervals. Okay, don't go and write down. And again, for some reason, everybody does it. You always go and do the wrong one, where you go this and you go 10 and then 18 and then 19 and then 20. Please don't do that. Okay, that's not a proper number line. Has to be a proper number line. All right, last question, and then I'm gonna let you guys start working because I've talked for like 40 minutes. Find the median. So here are our numbers. Is it there in your notes? No, it's not. You got the numbers there, okay? But for the median, do you guys remember what the median is? Middle number. Okay? Easiest way to find the middle number is you can literally just go and count them off one by one from the side. So there's there. But that takes a little bit too long. Okay? Shh. Last thing. To find the median, here's a formula. I'm going to give you a formula for it. I don't know if you guys have learned it before, but the median is equal to n plus 1 divided by 2. Okay, where n is number of numbers. Okay, now this essentially, what this does, actually I'll be a bit more accurate about it. This is the location of median. Not just the median, but where it is on the number line. So use this formula to find it. N plus 1 divided by 2. So here, if I actually use that, how many numbers do we have here, guys? You want to count? You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers, yeah? So what you'll do is you go 15 plus 1 divided by 2. That equals 16 divided by 2, which is 8. So the 8th number is the median. So you're going to go 1, 2, 3, 4, 5, 6, 7, 8. Right there. Nice and easy. You'd have to go side by side each time. Yes? We'll go through that when we get there. But for now, let's just keep it to that. Okay, so the 8th number is the median there. Does that make sense, guys? I think that's going to be it for now.